Greetings to all. Myself Parth Shah, a student of CEPT University pursuing my Masters in Construction Engineering and Management. The main objective of our Studio 2 is to enhance our practical understanding by studying and analyzing real-life construction projects. Through various site visits, data collection, technical analysis, and using different tools and techniques, we aim to bridge the gap between theoretical learning and on-site execution. This portfolio here includes 4 core assignments, each focusing on a vital aspect of construction management. First is the project brief, which focuses on studying the scope, objectives, and design considerations of a major brownfield redevelopment project, including its technical details and the scale of the project. Second is a pore planning, which involves detailed planning of two identical pores of basement 1 and basement 2. This also includes estimation of quantities for formwork, reinforcement, and concrete. Further, labor productivity was also analyzed. Third is the material and inventory management, which explores the end-to-end process of material procurement, flow control, and inventory optimization using different tools and techniques. The last is the earned value analysis, which investigates the project performance in terms of cost and schedule by applying EVM principles and performing comparative scheduling analysis using both MSP and Primavera tool. Let us now begin with the first section. Starting off with a project brief, this gives an overview of a major brownfield redevelopment project, which is the transformation of railway station into a modern and world-class transport hub. The MMTH, which is Multimodal Transport Hub, integrates various forms of transportation, enhancing connectivity and commuter convenience. The project scope here consists of several key infrastructure components. These include two 16-story commercial towers that will accommodate offices and a concourse area spanning 54,900 square meters dedicated to passenger amenities and commercial activities. Additionally, a 6-lane elevated road with a total length of 8.6 lane kilometers is planned to facilitate smooth vehicular movement. Two parcel buildings are also a part of this redevelopment, designed specifically to improve the logistics and handling of goods. With an approximate total project cost of massive 2,400 crores and a footprint of 125 acres, this project aims to increase the passenger capacity from 1.2 lakhs to 3.2 lakhs daily. The type of contract over here is EPC contract with an expected duration of 36 months, targeting its completion by 2027. Moving on with the pore planning, which is a critical aspect of construction sequencing. Proper planning avoids undesirable construction joints and ensures resource optimization. For this study, pore 4 and 5 from basement 1 and pore 6 and 8 from basement 2 were considered. These pores are identical in design, allowing consistent planning. The grid considered for calculation of couple elements was 297 meters square. The quantities of plywood, aluminium shuttering, reinforcement steel, and concrete were all calculated individually, along with labor productivity and cost estimates. Over here, for beam and slab, conventional formwork was being used, and for columns, aluminium formwork was being used. And in the layout, the non-shaded area shows the PT slab, which is of 300 thickness, and the shaded purple area shows the non-PT slab, which is of 250 thickness. For formwork planning of pore 6 and 8, as I mentioned earlier, aluminum formwork was being used for columns and plywood formwork was being used for beam and slabs. From this analysis, approximately 64 plywood panels, each measuring of 1.22 meters into 2.44 meters, were calculated to be required for beam shuttering based on the total beam surface area. For slab shuttering, a total shuttering area of 967 square meters for pore 8 and 1648 square meters for pore 6 was considered, with detailed calculations determining the exact requirement of plywood and other scaffolding elements, which is 595 and 353 plywood panels for pore 6 and pore 8 respectively. Column shuttering involved the use of aluminum formwork with 16 columns in Pore 6 and 19 in Pore 8, requiring about 21.45 square meters and 10.55 square meters for shuttering area respectively. The couplog system for slab and beam support was also calculated using standard coefficients. These elements were determined using a coefficient-based approach considering a 297 square meters grid layout. The detailed breakdown allowed for accurate labor estimation and minimized excess inventory on site. Labor productivity for beam and slab shuttering was found to be 0.27 square meters per man hour and for column shuttering 0.08 square meters per man hour. Total formwork cost was computed by combining material and labor cost. This planning ensures that the required resources are mobilized in a timely and cost-effective manner. Moving on with the reinforcement planning, where after properly studying the structural drawings, we came up with the quantities that will be required for pore 4 and 5 and pore 6 and 8. To assess cost efficiency in material handling, a comparative analysis between manual labor and tower crane was also carried out. The cost of manual shifting was calculated at 19,793 rupees, while shifting with tower crane amounted to be only 2,825 rupees, clearly indicating the economic and logistical advantage of mechanized lifting. Thus, proper estimation and handling methods can significantly reduce the reinforcement-related delays and costs. In concrete planning, the quantity of concrete that will be required for these pours was calculated. The coefficient of concrete usage was calculated to be 0.41. Here, M70 grade concrete was being used for columns and M40 grade concrete was being used for beam, slabs and ramps. Material proportions were also studied and based on its mix design, the corresponding costs were determined. Labor cost was calculated by assessing the manpower required for these pours. Proper planning over here ensures timely concrete delivery and consistent quality. Material management focuses on fundamentals of material and inventory management with an emphasis on structured procurement and storage processes. A steel storage yard measuring of 70 meters by 35 meters has been planned with designated zones for different bar diameters. Similarly, a material inventory store measuring 25 meters by 11 meters is used for categorizing MEP items and other weather-sensitive materials. Proper labeling, covering, and systematic racking have been implemented to minimize wastage and ease retrieval. The vendor selection process outlines the procurement flow from vendor selection to final delivery, ensuring traceability and compliance with specifications. This includes vendor registration, technical and financial evaluation, and periodic performance reviews. The third flowchart, which is the material requirement raised over here, starts with material requirement raised MRR followed by approval and generation of an issue slip. If materials are unavailable, a reorder level check initiates a purchase request. This leads to procurement approval, PO generation, vendor supply, inspection, and final issuance. It ensures timely and systematic flow of materials to the construction site. This organized layout and process supports a lean construction approach and ensures smooth site operations through real-time material tracking. Inventory classification was done using both HML and ABC analysis to improve control and efficiency. HML, which means high, medium, low, classified materials based on its unit cost. For example, binding wires and steel bars fell under the high category due to the higher price per unit. ABC analysis ranked items by the total consumption value. Items like cement and reinforcement, which form a large part of the budget, were categorized as A and B class materials. Using these methods, items were prioritized for tighter monitoring, helping to reduce overstocking of costly items while ensuring uninterrupted supply of frequently used ones. Using both the methods improves both cost control and operational efficiency. This analysis enabled the team to prioritize, monitor, and avoid unnecessary stock accumulation of high value or frequently used items. In this, economic order quantity model helps us determine the most cost-effective order size by minimizing total procurement cost, which includes ordering, carrying, and purchase costs. For this analysis, 10 different price points of steel were evaluated to identify the most economical order size by using the price break EOQ model. The optimal economic order quantity was calculated as 72.11 metric tons, which minimized the total cost, including ordering, carrying, and purchasing costs, to 24 crore 56 lakhs 76,075 rupees. This analysis demonstrated that as the unit price of steel decreased, the total procurement cost also reduced significantly, promoting bulk procurement as a strategic advantage. As the steel price decreased, total procurement cost also dropped, highlighting the benefits of bulk purchasing and effective planning. Earned Value Management, or EVM, is a performance measurement tool that combines scope, schedule, and costs to provide accurate project control. In this analysis, three main metrics were evaluated. First is BCWP, which stands for Budgeted Cost of Work Performed. Second, BCWS, Budgeted Cost of Work Scheduled, and ACWP, which is Actual Cost of Work Performed. For two consecutive look-ahead periods, from 1st to 15th March, values of BCWP and BCWS were equal, resulting in a Scheduled Performance Index, which is SPI, of 1, indicating that project progress was on schedule. However, the actual cost slightly exceeded the planned value, leading to a negative cost variance. This reveals that although the work is proceeding as per plan, the project is marginally over budget. Schedules were prepared in both MSP and Primavera. While the scheduling results were similar, Primavera offered better cost tracking. This dual tool analysis emphasized the value of unified progress tracking for accurate project monitoring. Thus, concluding this integrated approach followed throughout the studio, poor planning with detailed quantity estimations and productivity metrics highlighted the importance of sequencing and resource optimization. Material and inventory management applied analytical tools like HML, ABC, and EOQ to optimize storage, reduce cost, and ensure timely supply. Earned value analysis helped measure project performance accurately in terms of both schedule and budget, using MSP and Primavera for comparative insights. These comprehensive assignments collectively enhance technical proficiency and practical understanding of real-world project execution. Thank you.